Lesson 4.8 is solving problems with trig. So this is drawing pictures and solving problems using our trig functions like sine, cosine, tangent. Okay, I guess officially you could use the reciprocals too, but usually we go with sine, cosine, and tangent. Now, a couple of definitions before we jump into these. Angle of elevation. You probably have an idea, but angle of elevation, the angle through which the eye moves up from the horizontal to look at something above. So this is, if I'm looking up at the sun or looking up to the top of a building. The angle of elevation is the angle between the horizontal, so like horizontal straight out or the land, and then my line of sight. So that's angle of elevation. Angle of depression, just the opposite. Officially it reads the angle through which the eye moves down from the horizontal to look at something below. So this would be like, okay, standing at the top of a building. The angle of depression is the difference from, okay, if I was looking straight out versus my line of sight when I then look down. Okay, so angle of elevation, angle of depression. I think those are kind of, I shouldn't use the word obvious, but I think those are something you kind of already know. But just for some wording there. So let's look at example 1. The angle of depression of a buoy from the top of the Barnegat Bay Lighthouse, 130 feet above the surface of the water, is 6 degrees. Find the distance x from the base of the lighthouse to the buoy. Well, what am I going to start with? What? A picture. I'm going to start with a picture. The picture can be fancy. It can be pretty simple. Okay, so we have Barnegat Bay Lighthouse. Well, I am not an artist, nor will I ever claim to be. My lighthouse is going to be the same thing I draw for a building. You can make your lighthouse a straight vertical line if you want. I don't care how you draw it. But that is my lighthouse. And what do we know about this lighthouse? See, the angle of depression of a buoy from the top of the Barnegat Bay Lighthouse, 130 feet above the surface of the water. So what is that saying about this lighthouse? Yeah, it's 130 feet tall. Okay, and then we're looking at buoy. We all know what a buoy is, right? A buoy being bobbing in water, right? Out marking something. So, my buoy, I'm going to put over here. I'm just using a little dot, but there's my buoy. The question we're being asked to find is find the distance x from the base of the lighthouse to the buoy. So I'm trying to find that horizontal distance between the two. And then it also gives us an angle of depression. What are we forming here? A triangle, and specifically a right triangle. And that's what all of these. We can't use our trig functions if we don't form a right triangle. And which is why I said your lighthouse could just be a vertical line once you realize, oh, these are all triangles we're drawing. Now, the angle of depression is 6 degrees. Now, keep in mind, it's the angle made with the horizontal. So what this dotted line is representing is the horizontal, like looking straight out. The angle of depression, then, is the angle between that and my line of vision. Well, my line of vision is basically the hypotenuse. And so do you see that the 6 degrees is right there? Is that where you would have put it?
Yep.
That's what I'm hoping. Okay. Okay. Thoughts here?
Well,
Did they work like that?
Okay. So can we put the 6 degrees down by the buoy? Does it work like that?
No.
I totally get your question. I totally get it. It just seems like they should be the same. Is that what you're feeling?
Yeah.
Okay. How well do we remember our geometry?
like 90 minus
The geometry, okay, it's been years. I've never taught geometry, so I'm just going based off of what I remember. But there is is it a theorem or, I don't know, two parallel lines cut by a transversal, then alternate interior angles are congruent. Okay, so here, two parallel lines, right? Cut by a transversal, which is the hypotenuse. Alternate interior angles, so the angles inside the parallel lines on alternate sides of the transversal. So yes, is that angle down by the buoy 6 degrees? Yes, it officially is. Okay? Other than it just seems like they should be the same, which I totally get. It does seem like they should be the same. Now, if you didn't remember that piece of geometry, what were some of the rest of you maybe thinking about doing? Because we need to have an angle inside the triangle. Well, even if we didn't know this is 6, how could we find this angle right here?
90 minus 6.
Yeah, this forms the horizontal and the lighthouse form a right angle. And so if you do 90 minus 6, this is 84. Okay. I mean, ideally, you don't have to do any math if you just put the 6 in there, because it's the same. But if you didn't see the 6, you could put the 84 there, and that works as well. Okay. How do I find x? Notice it's solving problems with trigonometry. Why would we use tangent? Yeah, so Katoa, tangent is opposite adjacent. So, and officially, you have two choices. I personally was going to use tangent of 6 degrees is equal to what? 130 over x. If you're someone you're like, oh, but I want to use tangent of 84. Then you could use tangent of 84 and it would just be x over 130. Okay, how do I solve for x here? If it's 130 divided by x, we need to multiply by x. So officially I could say x times tangent of 6 degrees equals 130. And then, if we're trying to solve for x, it's going to be, divide. So 130 divided by the tangent of 6 degrees. And now you grab a handy dandy calculator, which needs to be what mode? Degrees, because it's tangent of 6 degrees. And in fact, most, if not all of the homework problems, you'll need to be in the degree mode. So 130 divided by tangent of 6. And you should get an answer that matches mine. If by chance you did use tangent of 84 equals x over 130, then you would just be doing 130 times tangent. Whoops. What? Oh my gosh, it won't let me fix it. Yikes. And that would give you the same answer. That's what the math would be if you had set up with 84. Okay. I have my answer to 2 decimal places. So 1,236 and 87 hundredths. 1236.87, and that label is going to be feet. That is the basics behind what we're doing today. Everything is about setting up a triangle. I'll be honest, majority of your homework is going to be about using tangent. I'm not going to say always, but majority of it, you're going to see a lot of tangents in homework, which means a lot of times you're going to know the two legs and not the hypotenuse, right? which is fine. Okay, let's look at example 2. From the top of the 100-foot tall Altgate Hall, a man observes a car moving toward a building. The angle of depression of the car changes from 22 degrees to 46 degrees during the period of observation. How far does the car travel? Obviously, we went from the easy peasy level to the more difficult level quickly, right? So that's how it works. Okay, we have a building. Can you guess my building and my lighthouse are going to look a lot alike? Get fancier if you want, but here's my hole. Okay, from the top of a 100-foot tall hull. And if your hull is just a straight line, then so be it. Draw just a basic triangle. A man observes a car moving towards a building. Well, this car is basically in the same place that the buoy was last time, right? It's what we're looking out at. I'm going to put my car pretty far out because I need some room to work here. Sorry, I'm not even drawing a car. You just get the word car. Draw a car if you want a car. Now, it talks. I feel like I should have made my building a little bit taller. You know what? My building just magically grew a couple stories on top. Okay, so from the top of this 100-foot tall hull, he observes the car moving toward the building. The angle of the depression of the car changes from 22 to 46. How far does the car travel? So notice what the car is doing is it's traveling towards the hull, yes? And as it's moving towards the hull, we have it in two locations basically. We have it where it started, and then we have it at another point that it was observed. And so what we're trying to find is that distance right there. Because we want to know how far does the car travel during this period of observation. I'm going to call that X. Okay, I'm drawing out my horizontal for reference sake, not that you have to draw yours out. When the car was first noticed, the angle of depression was 22. So that 22 is from the horizontal to the longer hypotenuse, going all the way out to where that car was observed. Now, if that's 22, what else do we know? The angle down by the car, where the car starts, is 22, yes? Then, this car moves closer towards the building, and then the angle of depression is 46. And that's going down to the other hypotenuse, the hypotenuse of the small triangle. Now, if that's 46 degrees up here, guess what? We've got a 46 degrees down here. Now, here's the problem. We need to find X. X is not the side of a right triangle. It's the side of a triangle, but the whole point today is to use trig functions, which means we need right triangles. So we're going to have to work with our right triangles that we have to do this. What if I say I see two right triangles? Can you see two right triangles? They overlap, right? We have the small right triangle that has this 46 degrees in it. And then we have the bigger right triangle that includes the smaller triangle that has the 22 degrees in it, yes? We're going to have to use those two pieces to find X. Meaning, we can find the smaller distance, right? which I'm just going with what I have in my notes, and I called that D in my notes. Call it whatever variable you want. But can we find D? Yeah, that's a right. Here, let me put a right angle. That's a right triangle, so we could find D. And then we can use the big triangle to find what? The whole distance, which, sorry, I was even trying to avoid going down into that bottom example, and I'm still doing it a little bit. But the idea is that x plus d is y. Well, we can find d on the small right triangle and y on the big right triangle. Can we then find x? Yeah, it'll be basic subtraction. So let's start with finding y. The whole big right triangle. How can I find y? No. We're trying to find the length of y. Tangent of 22 degrees is going to be equal to 100 over y, because it's opposite over adjacent. So tangent of 22 degrees is 100 over y. I can zoom that in for a moment before I have to move over. Are we okay? That's looking at the whole big triangle, right? 22, opposite is 100, adjacent is y. So, multiply the y over officially, right? Y times tangent of 22 degrees equals 100. So in order to do y, we're going to do 100 divided by a 247 number. 247.5086853. You don't have to necessarily write all those pieces out. And the good news is if I leave it on my calculator, I can always go and grab it, right? Now what? I found y. I know the whole big long distance. What else can I find using a right triangle? D. So D, we're using this small triangle, so that means this time we're using the 46 degrees. Tangent of 46 degrees, opposite over adjacent, so 100 over D. Multiply the D over, divide by tangent of 46, and D is going to be 100 divided by tangent of 46 degrees. Did you get a 96 number? (96.568877), a bunch of stuff. How do I find what I need to find? Yeah, if we're trying to find x, we're going to do y minus d, which, I'm not going to write those out. Y is this 247 number, minus d is this 96 number, and approximately 150. I have 150.9398078. As long as you're good to two decimal places, 150.94. So that's 150 and 94 hundredths feet. Okay, there's your challenging type problem, right? Takes a little bit more work, but work to figure them out. They're doable. Now, I have one last question to look at. It's actually a quicker question. It's just a triangle. And in the triangle, you have sides of 62 and 25. and you have an angle of theta. And the directions are find theta. Okay, you see a connection of tangent? Because SOHCAHTOA says tangent is opposite over adjacent. And so I can write this statement. The tangent of angle theta is equal to opposite over adjacent, 25 over 62. Now, here comes the big question. How do we find theta? So what allows us to solve for theta, or to move that theta out of there? What did we learn about in the previous lesson? The homework we graded today was all about what kind of functions? Inverse functions, right? What does an inverse do? Takes the x values and the y values and switches them, right? So our sine, cosine, and tangent inverses, we took our input and our output and we switched them. So right here it says tangent of theta equals 25 over 62. Well, if I change this and I use the inverse, we're going to say what? Tangent inverse of 25 over 62 is going to equal theta. So the inverse allows us to switch the input and output. And can your calculator take over from here? It has to. We don't have a way without the calculator, okay? This is not one that's on our chart. So, second tan, 25 over 62. And by the way, what setting should we be in here? Degrees. It's a triangle, yes? How are you going to give the angle of a triangle? Degrees, unless it states, otherwise. And we get 21.96056402. Does that seem reasonable? Yeah. So I'm going to go 2 decimal places. So theta is approximately 21.96 degrees. Do make sure you put the degree label on there, especially since it didn't specify. So I guess technically if you put radians, I don't know if I'd be able to count it wrong or not. It didn't specify. It was just using logic that we decided on degrees. Okay. Your homework for tomorrow. Page 393, 1 through 16, 19 through 24. Sometimes they provide the picture. It's so helpful. Other times, I'm thinking you're going to be drawing a picture. There's a lot of use of tangent. A lot. Okay? Almost all of it's tangent. It's doing a lot of what we did here. So, work to figure them out. Needless to say, it's all word problems. Bring it back tomorrow. We will check it and go over questions. And I will also have Chapter 4 review worksheet, actually I already have them, ready to hand out.